Good day everyone. This is the field demonstration of the RheoSol system. Based on the RheoSol objectives, we are going to show you how to operate the system. First, plug the mini USB port into the solar controller. Enable the Wi-Fi connectivity and click RheoSol access point. Input the password to connect into the system. Second, open the RheoSol application by clicking the Start button. The RheoSol application will display the level or status of nitrogen, phosphorus, potassium, pH level, tank, well, as well as the temperature and humidity. As you can see, the NPK status are all in depleted or 0 mg per kilogram. It is because the NPK sensor is not already in use. So trying the NPK sensor, we will able to measure in real time as we can see it on the display on the smartphone. Now, the level of the nitrogen is in deficient with 40 mg per kilogram. The phosphorus is in depleted with 16 mg per kilogram. And the potassium is in depleted with 15 mg per kilogram.
Next in the objective is the status of temperature and humidity. As you can see, it displays 24.6 degrees Celsius with 95% humidity due to low temperature here in Barangay Kapatagan near the highest peak in the Philippines, Mount Apo. This is the DHT11 sensor we used in measuring temperature and humidity. It is capable in measuring with an open area spaces. Another objective is to display pH level of water. So this is the pH sensor. We set this as an example only to determine the neutral level of water we use, that is 6.9. Next of the objective is the status or level of the tank and well. As demonstrated, it displayed that the tank is in critical. To confirm that, we will show to you the physical status of the tank. As you can see, the tank is empty. That is why status of the tank in the smartphone is critical.
So, here we can see the solenoid valve. This is the one to control the output water flow to the crop plant. The system adapted the feedback mechanism loop where if the soil moisture sensor detects that the soil in the crop is dry, the valve will open for provision of water, and if it is wet, it will automatically close the valve. This is the output water flow of the system. Moving forward, as you can see, that is the solar panel. It is connected to the main RheoSol device which allows to charge the battery. Based on our objective, the device can harvest solar energy to power the whole system.
Furthermore, as one of the objectives, our system were able to send emergency notification via SMS to the owner in case of critical failures. As you can see, the well is in low status, and this time it will send to the farmer mobile phone which states ang balon ay kasalukuyang nasa critical na level na ng tubig. Second notification is the tank leakage. As you can see, the status of the tank is critical, and it will automatically text the owner stating ang tangke ay kasalukuyang nasa critical na level na ng tubig. Posibleng may butas. The pump is on state to fill the tank as demonstrated. The status of the tank in the smartphone will change into low from critical by confirmation that the float switch is working. As shown in the display, the pump status is failure because we cut the power of the pump, assuming that leads to break off in water flow, which detects by the flow rate sensor that the pump is not working. The system will now text to the owner stated, ang pump ng RheoSol ay hindi na gumagana at ito'y nangangailangan ng pagkukumpuni.
With the guidance of our advisor engineer Reynanti Aliling, we have masterfully succeeded in implementing our device objectives to its full functionality.